All right, hello. Happy Friday. Today we're going to learn the new unit. It's all about polynomials. So we've kind of talked about polynomials a little bit before when we talked about monomials. And remember, a monomial was when we had one term. So right here, where it says monomial, there's just one term there. There's no plus or minus sign. There's just one piece. A binomial, remember the prefix bi, bi is 2, so that means a binomial has 2 terms, and they're separated by a plus or a minus sign. And then a trinomial, like a tricycle, has 3 terms. 1, 2, 3 for a trinomial. But anything that has any number of terms is called a polynomial. Poly is just many, so any number of terms is a polynomial. The leading coefficient, if you look at any of these polynomials, the leading coefficient is the number that's out front, the number that's in front of the highest term. So for example, the monomial's coefficient is 3, the binomial's leading coefficient is 2, and the trinomial's leading coefficient is invisible, but it's a 1. Usually when we write our answers, we write them in standard form, which is when you have the highest exponent first. So if you look at this example, the highest exponent here is a 5. And then we have a 4, a 3, a 2, an invisible 1, and then no exponent at all. And you can actually skip some. So for example, if there wasn't even this term here, that's still in standard form, just highest to lowest exponent. All right, so for today, we're going to focus on just adding and subtracting the polynomials. We'll learn about multiplying and dividing later. So adding polynomials is the easiest. If you look at these problems here, number 1, I'm going to add the following polynomials. So there are parentheses in this problem, but if you look, the parentheses aren't actually doing anything at all because there's no number out front of either of the parentheses. There is technically a 1, but if we were to distribute a 1 and multiply by 1, that doesn't change any part of the problem. So in number 1 right here, the parentheses don't matter. So if we pretend like the parentheses don't exist, we just can combine all the like terms. And like terms have the same variable and the same exponent if there's exponents. So for example, in number 1, we can combine negative 7x with 8x because they both just have an x. So negative 7 plus 8 is 1. We can put 1x or we can just put 1, your choice. All right, so then if I keep looking, there's a 9y, which has a like term with negative 3y. Add those together, 9 plus negative 3 is 6y. And then the last two have these, so 15z and negative 8z. If we add 15 and negative 8, we get 7. So 7z. And that is the answer. We've combined everything we can combine. That's as simplified as we can make it. So now number 2, that's another one we're adding, and I know it's adding because there's a plus sign in the middle. Again, look at the parentheses. There's nothing out front that needs to distribute, so we can ignore the parentheses and just combine the like terms. So I'm going to start with the one on the left. 3a squared doesn't have a partner. So I'm just going to bring it down. 3a squared. 3ab has a like term with 4ab. If I add those coefficients, 3 plus 4 is 7. And the last two, I have negative b squared and 6b squared. We can put a little 1 here. And they are like terms. So negative 1 plus 6 is 5. So 5b squared. Remember when we combine them, the letter part doesn't change. So notice that stayed a squared and ab and b squared. We're just combining the coefficients. All right, so sometimes we'll get a word problem. But we just have to decide what we're doing to the things in the problem. So we've done this before, so we can circle the numbers and we can underline the math words. It says, well, Stacy loves the wild rabbits in her backyard. She would like to keep the little critters out of her vegetable garden. If her vegetable garden is a rectangle whose width is represented by 5x squared plus 3x minus 9, and whose length is represented by 2x squared minus 2x plus 4, what is the perimeter of the garden? So these are numbers, and the whole thing is actually, we can consider it a number in this problem. Looking at the math words, I see width and length. I see perimeter. I think that's all the math words I can see. And then the question is, what is the perimeter of the garden? So that's my goal. My goal is to find the perimeter. So I'm just going to put P equals so that I remember that's what I'm just going to put. Oh, another math word because I need to know what to draw. So her vegetable garden is a rectangle. So now that I know what the picture is, I'm going to draw a rectangle. And then it also says that the width is represented by 5x squared plus 3x minus 9. So that's one of the sides. I'm going to write that on one of the sides. But if this is a rectangle, then that's also on the other side. All right, it also tells me that the length is 2x squared minus 2x plus 4. So that's the other two sides. All right, and then if you remember, we've done perimeter before. To find the perimeter of any shape, you just add up all of the sides. So perimeter means we're going to add. Now, when we're adding all these polynomials, we're basically just combining the like terms. So you can look all around the whole rectangle and find the like terms. I have a 5x squared, a 2x squared, a 5x squared, and a 2x squared. And we're just going to add those coefficients. So 5 plus 2 is 7, plus 5 is 12, plus 2 is 14. So 14x squared. And then I look at all the x's. I can add those up as well. So I have 3x, negative 2x, another negative 2x, and a 3x. If I add 3 plus negative 2 plus 3 plus negative 2, I get 2. And those had an x. And then lastly, we can combine the negative 9 and the negative 9. And that's 10. So that is our perimeter. We add all the little pieces up. All right, so this little box, this is a problem. These are called algebra tiles, and they are actually physical things that we can touch if we wanted to. But these are just shapes that represent different letters. So if you look here, some of them have a y, some of them have an x, some have a 1, and some have x squared. You're really just adding up everything that you have that's different from each other, kind of like combining like terms. So if I start on the left, over here, there are 4 y's. So I could rewrite that as 4y. There are also, just over here, there are 2 x's. So I'm going to put 2x. I see 3 1's, which is just 3, right? 1, 2, 3. And then x squared, there's just one of them, so that'll just stay x squared. And we want to add that to the other one. So we've got 3 y's over here. I have an x, 1x, or just x. And then there's 5 little ones. So now if I add up the like terms, we have, I'm going to start with the x squared. It really doesn't necessarily matter what you start with. X squared didn't have a partner. It's the only x squared, so I wrote that. There is a 4y and a 3y. So if I add 4 plus 3, I get 7. 7y. And then there's a 2x and a 1x, which adds to 3x. And then 3 plus 5 is 8. So that is my final answer. The only change I might make is to put the x first in front of the y, just because that's alphabetical, but I'm not super picky about the order. All right, so that's all adding. Adding polynomials, there's not an extra step. When we go to subtract, you'll see that there's an extra step, and I'll tell you why. If we look at number 4, in the middle there's a minus sign. So if we think about those parentheses and ask ourselves, do the parentheses matter? The first set of parentheses don't matter because there's nothing out front. There's a positive one, just like the adding one. So again, that doesn't matter. But the second set of parentheses has a minus sign, which is really a negative one. So we need to distribute that. Those parentheses matter. I'm going to distribute that -1 just to that second polynomial because it's out front. And so I'm multiplying. -1 times 8x is -8x. -1 times -3y is positive 3y. -1 times -8z is positive 8z. Now the first polynomial, remember we said that the parentheses don't matter. We don't need to distribute, so we just copy it. They stay the same. We don't need the parentheses anymore. You can put them, but you don't need them. But now that we don't have any parentheses, now we can just combine the like terms. There's -7x and -8x. If I add those, I get -15x, 9y, and 3y. 9 plus 3 is 12, so 12y. And 15z and 8z adds together to 23z. And that one's done. All you have to do when we subtract polynomials, the first step is you distribute the -1, and then you just combine everything. So last one, number 5. Again, if I look at those parentheses, I look in the middle, I see a minus sign. So now I know I need to do that extra step. Distribute the invisible -1 back behind it. So copy the first part. There's no need for those parentheses. So the second part, a -1 times 3a is -3a. -1 times 4b is -4b. And I can combine like terms. So 7a and -3a, 7 and a -3 make 4. So 4a. And then -10b and -4b add together and make -14b. And that one's also done. All right, so you can try the you-dos. And then on Monday, you can ask any questions if you still have questions. If you want to email me if you have questions, I won't check my email while I'm at home, but it'll kind of give me an idea of what questions you have at this point. All right, I'll see you on Monday.